Okay, in this video, what I'm going to do is go over problem number 1 from the Related Rates and Implicit Differentiation Review problem set. In this problem, we have a 13-foot ladder leaning against the wall. Second, we have the top of the ladder sliding down the wall at a rate of 2 feet per second. And that tells us that the rate of change of y with respect to x, if we consider the wall to be the y-axis, then the rate of change of y with respect to time, t, would be 2 feet per second. Now we want to find out how fast the foot will be moving away from the wall when the top is 5 feet above the ground. If we consider the distance of the foot away from the wall to be the x-axis, or the x value, then as y slips down, x is going to increase, since the hypotenuse, or the ladder, is a constant 13 feet in length. And what we're trying to determine here is what is dx dt, or what is the rate at which the foot is moving away from the wall at the instant when the top is 5 feet above the ground. So we've written down all of the information related to the problem, what we're given, what we're looking for, a diagram of the situation, and the next thing that we want to do is find some formula that is going to relate dy dt and dx dt, and we happen to know that that formula would be the Pythagorean theorem, or x squared plus y squared is equal to 13 squared, or x squared plus y squared is 169. The next thing that we're going to do is differentiate both sides with respect to time, and that will give us 2x dx dt plus 2y dy dt is equal to 0, since the derivative of a constant is 0. Now we're ready at this point to begin plugging in, and what we're trying to solve for is dx dt. So we want to isolate dx dt, and we want to find this out when y is equal to 5. We already know that dy dt is 2, and we don't know what x is, but we can solve for x. We want to find out what x is when y is equal to 5. And so we would get x squared plus 5 squared is equal to 169, x squared is equal to 144, or x is equal to 12 feet. It can't be the negative quantity since we're working with positive distance here. So we do know that x is equal to 12 in this situation. And without going any further, we can begin to plug in and solve here. So plugging everything in, we got 2 times 12 times dx dt is equal to negative 2 times 5 times 2. We just moved the 2y dy dt to the right side of the equation and made it negative. Simplifying, we get 24 dx dt is equal to negative 20. Divide both sides by 24 and simplify. Dx dt is negative 20 over 24, which is negative 5 over 6. And that completes the problem.